All right. Hello, everyone. Thanks for joining us for our webinar today, Lead Hazards in Schools, Controlling Lead Hazards from Paint and Drinking Water. Presenting today, who you can see on camera there, will be two of our own senior project managers, Lydia Feng and Steve Long. Lydia is a senior project manager at FACS and has over 10 years of experience in the environmental health and industrial hygiene field, assessing chemical and physical hazards to human health. She's managed and provided assistance in numerous environmental health and industrial hygiene projects, including chemical exposure assessments, indoor environmental quality assessments, Legionella water quality assessments, and mold and moisture assessments. Her projects have taken place in a variety of settings, including schools, hospitals, laboratories, constructions, sites, industrial facilities, and residences. And Steve is also a senior project manager, like I mentioned, and he's been with FACS for over 20 years and has over 20 years of experience in the IH field, specializing in asbestos and lead-based paint projects. He manages projects through survey, design, and abatement phases and has worked on various IH surveys, audits, indoor air quality investigations, and asbestos and lead inspections. Steve's provided lead-based paint abatement project management and environmental assessments for national property owners, real estate development firms, utilities, government, and of course, schools. But before I hand it off to Steve and Lydia, I'm going to quickly cover just a few components of the webinar platform. If you have any questions throughout the entire presentation, you can enter them in the question field in the top right of your GoToWebinar platform. Submit those there, and at the very end during the Q&A session, we will cover those questions and have Steve and Lydia answer those for you. So with that, I will hand it off to Lydia and Steve.
So we'll start with our agenda for the session. The first element will be some background information on health effects of lead. Then we'll get into lead in school paint and soil, starting with background of sources of lead exposure and also best practices for reducing lead exposure from paint and soil. Lydia will present the second session, which is lead in school drinking water. She'll discuss results of recent testing and also best practices for reducing lead exposure from drinking water. So, some background information on the health effects of lead in children. Exposure to lead can seriously harm a child's health, and we see some of the examples here. It can cause damage to the brain and nervous system, slow growth and development, learning and behavior problems, and even hearing and speech problems. So the EPA and CDC have stated there is no safe level of lead in children. We can see lower IQ, decreased ability to pay attention, and underperformance at school. So there are many sources of lead in a child's environment. Some examples here are lead from paint and the dust that's created from, say, friction of opening and closing a window, things of that nature. We have some exposure from air. That was much more dramatic before the banning of lead in gasoline for automobiles. We have potential for lead exposure in drinking water, and even in food, candy, and certain folk medicines have been created with lead in them. Parents that work in a job that may expose them to lead have the potential to bring it home on their clothes, in their car, and expose their children that way. And finally, toys and jewelry, plastics, some of these have been found over the years to contain lead. So let's talk about lead in school paint and in soil. There is a regulatory environment that's designed to prevent exposure to lead for children, and that starts with the HUD guidelines. This is a book created by the Federal Housing and Urban Development Department. It's kind of a how-to for controlling lead-based paint exposures and also for measurement. And it's referenced by many regulations incorporated by reference. EPA has created the RRP rule, or Renovation, Repair, and Painting rule. This rule to prevent exposure to lead applies to residential and child-occupied facilities. So for schools, child-occupied being defined as under 6 years of age, this would be primarily your pre-K and kindergarten students. California has their Title 17 regulations for lead. This is applicable more broadly to public and residential buildings. So that would obviously include schools. It excludes things like factories, industrial settings. And this is something we work with a lot, with FACTS having many offices in California. For workers, the federal OSHA and also Cal OSHA have their lead in construction standards, which provide workers protection for those that are maybe disturbing paint in relation to construction. Again, in California, we have the 1992 California Lead Safe Schools Protection Act. And one of the key provisions there that is more protective than most is that paint in schools applied before January 1st, 1993 is presumed to be lead-based paint. So this is a protective assumption, whereas most regulatory standards you're going to see in other states and federally use a cutoff year of 1978. And then finally, there is some hazardous waste implication potentially for lead in that the levels of lead in paint can exceed the levels to classify it as hazardous waste. So if we're scraping paint, the waste created from that may well be a hazardous waste. So testing is important to determine that. So why was lead used in the first place? We have seen some of the issues, some of the problems with it. And these are some of the reasons why it was seen to have good industrial properties and actually continues in certain types of uses, such as batteries, to have important benefits. So in paints, it can prevent corrosion. It can kill mold and mildew. In its elemental form, it's easy to shape. So think fishing sinkers. It's strong. It blocks radiation in a medical application where you're taking x-rays. Blocks sound due to its density. And again, in paint, it helps the paint to dry faster and also adds color and brightness to the paint and helps it sustain that over time. For lead in soil, we have various sources. The first one here, specific to schools, artificial turf on athletic fields. So there has been some testing of this turf, and some of them have been found to have some lead, which obviously can be a subject of direct exposure and also indirectly get into the soil through wind and soil runoff, water runoff into the soil. There is still some lead in gasoline out there. The piston-driven aircraft, the older aircraft still use lead in their aviation gas. Historically, lead has been used for automobile wheel weights to balance wheels, and these can fall off from time to time and basically get ground up on the roadways. So it can again end up in the soil due to wind and water, as can the lead that was used historically in brake pads. We have industrial air emissions. So something like a battery factory may have some emissions of lead, and there may be some fallout in the nearby communities onto soil. In construction, in addition to paint, we have some welding and soldering that may be occurring that may be releasing some lead into the air, and that can find its way through fallout into the soil. And finally, we have ammunition, where lead is present in both bullets and in the powder, and then fishing weights as well. In terms of jobs and hobbies, many of the construction trades have the potential for lead exposure. Of course, dealing with paint, disturbance of paint, lead abatement workers, carpenters, you have welders, demolition workers, all with the potential for exposure. Industrial trades like lead miners, lead smelter workers can have exposure, and numerous other trades, gun firing range workers, police officers, artists with their paints, etc. So children can be exposed through take-home exposure, such as when the parents come home with contaminated clothes or they spread contamination into their cars. When does lead paint become a hazard? Well, when it's deteriorated in some way. So we see a picture here of what we call alligatoring, where the paint is basically peeling off the surface in a certain way. We can have friction or impact surfaces that disturb paint, such as sliding windows, door frames that are rubbing on the door. And if we have small elements like railing posts, for example, then these can become a chewable surface. Other ways of disturbing paint include things like water leaks, construction. And then this results in lead dust on surfaces and in soil. So lead dust particles, and it can be such that it's actually invisible to the naked eye and still be problematic. These can then become breathed or swallowed. So touching surfaces covered with lead dust can result in ingesting lead through hand-to-mouth activity, eating, for children playing, normal hand-to-mouth, and also applies to smoking and applying cosmetics. Children are especially at risk for lead poisoning because they are often, of course, putting their fingers and other objects they may be playing with into their mouths. And if there's lead in the environment, these may have lead on them. Symptoms of lead poisoning can be confusing because they are the same as other common illnesses. So this can result in misdiagnosis or delayed diagnosis. So for example, attention problems, learning problems, these can be caused by many other issues besides lead poisoning. So we've heard before that CDC and EPA say there is no safe level. So then if there's no safe level of lead, how do we establish permissible levels? Well, that's because many times the PELs are based not so much on health, but other factors. So one big one is that we can only regulate down to a level that we can measure, right? So we can't regulate lower than the analytical sensitivity. So in light of that, in 1978, the lead-based paint definition was defined as this threshold of 5,000 parts per million of lead or above, or equivalently 0.5% by weight. Or when we use a different measurement method, which measures by area, threshold is 1.0 milligrams of lead per square centimeter of surface. So these thresholds were based on the accuracy of what's called an XRF instrument, X-ray fluorescent instrument, that is able to directly measure lead in paint. So not based on health-related issues. Also in 1978, the allowable amount of lead in paints sold to the public was reduced from that 5,000 part per million level down to 600 parts per million. So almost a 10-fold reduction. So in 1978, the level that a XRF instrument could be considered to measure in both an accurate and precise manner was this 1.0 milligram per square centimeter. So this is what became established as a threshold for lead-based paint. There are some jurisdictions in the country that use lower levels, such as the County of Los Angeles uses a level of 0.7 milligrams per square centimeter. Now, the 0.5% by weight and 5,000 parts per million, these are numbers that you see when you take a sample of the lead paint and send it to the laboratory. Then they give you one of these types of measurements. These are half the level that was seen before that in 1973 of 1% and 10,000 parts per million as the lead-based paint threshold. Now, although lead-based paint is defined as above, at or above the 1.0 milligram per square centimeter, or 5,000 parts per million. That's not to say that lower levels of lead in paint can't still be a problem. So it is still important to use good work practices, even when we have these newer paints that have less lead. So if we look at a paint that is right at the threshold of 5,000 parts per million, and we imagine 1 square foot of that paint being sanded off completely, which would be one removal method. If care was not taken, the amount of lead that comes off of that process can contaminate up to 23,000 square feet of floor surfaces above the current California Department of Public Health and EPA hazard level. So if we look at even lower amounts of lead in the paint, 600 parts per million, which was the limit that was established in 1978, that same 1 square foot of paint can still contaminate 2,300 square feet. So that's a decent sized house. And then finally, the level that we're at now in terms of a limit in paint sold to the public is 90 parts per million since 2009. So even in that scenario, it's possible to contaminate over 300 square feet of surface from that 1 square foot of paint. Fortunately, we do have a good test for measuring lead exposures. We don't have that with all different types of contaminants, but we do have it with lead. We have 2 tests, the BLL or blood lead level and ZPP or zinc protoporphyrin test. The difference between the two is how far they can reach back to tell us about exposure. So the BLL test shows exposure that has occurred within the last 6 to 8 weeks. And it's measured in micrograms of lead per deciliter of blood. After that time period of 6 to 8 weeks, the body has processed most of the lead out of the blood. So it's time limited. The ZPP, though, is able to look back even farther to show an indication if there's been lead exposure in the past. So we're back to permissible limits here, or what EPA calls their lead hazard levels. So lead levels are to be kept below these numbers. Anything above that is considered a lead hazard. So in bare soils accessible to children, that would be 400 parts per million. In other areas where children are not expected to be playing or exposed, the limit is 1,200 parts per million. And on interior floor surfaces, the level is very restrictive, very low, at 10 micrograms of lead per square foot. So just to give you an idea how small that is, a microgram is a 1/1,000,000th of a gram. A gram, of course, being only a fraction of an ounce. So this is a very small amount that is the permissible limit, and EPA is proposing to lower it even further. Windowsills being less of an exposure hazard than a floor, the level is set at 100 micrograms per square foot. So now let's talk about methods of control, methods of compliance. So one good step is to identify where you have lead in paint and at what level. So the picture here shows an XRF instrument, in this case measuring the window frame. And this instrument, in about 10 to 20 seconds typically, will give a reading to the operator showing them if there's lead in that paint and at what level. So this can be very helpful to planning construction work that maybe needs to disturb lead in order to determine where the more intense controls need to be implemented. Other practices to prevent lead exposure include the use of properly trained and certified contractors. So there's training that's out there for both the workers and the supervisors for work that will be disturbing lead-based paint. And there are processes that vary from different jurisdictions and different states to certify the contractors or the companies that employ the workers. And so the largest of these would be the EPA's RRP program, which is nationwide. And then we look at the use of lead-safe work practices. So if we need to disturb lead-based paint, maybe for repainting, it may be demolition of some, walls and things of that nature, then we want to be sure to implement lead-safe work practices, or in short, containment. So these would be practices that prevent exposure and capture dust, prevent us from leaving dust behind after construction work. So looking at the steps for that, first would be regulating the work area. So this would be accomplished typically with signage, warning people away, with barrier tape to keep people who shouldn't be in the area out of the work area. And also it serves as a boundary for workers to make sure that as they're leaving the work area, they clean themselves and are not tracking any lead outside of the work area. Containment of the work area involves basically ways to capture dust. So this is done typically through plastic sheeting, covering the areas that we don't want settled dust to contaminate. It's important to use proper tools and techniques to prevent creating a lot of lead dust or fumes. So an example of something that would be prohibited would be using a torch to basically blister off paint from surfaces. This would be a paint removal method that has been used in the past, but it creates a tremendous amount of airborne lead dust. And so this is not a practice that is used anymore. By contrast, if paint needs to be scraped, for example, to get off loose and flaking paint prior to repainting, wet scraping would be a good method for doing that, minimizing lead dust. Other elements would be covering all items or horizontal surfaces in the work area to prevent dust from landing on them. Covering and sealing windows and doors, again, typically done with plastic sheeting. Shutting off HVAC systems and covering openings like the supply and return openings. So this is going to prevent not only contamination of the system, but potentially circulation of lead dust to other areas. For the workers, they use respiratory protection and other PPE or personal protective equipment to protect themselves from the lead dust while they're working with it. And PPE would typically include gloves, disposable shoe covers, and disposable coveralls. And finally, the last step of a job that's going to be disturbing a lead paint is going to be cleaning up lead dust so that nothing residual is being left behind. So even after the pulling up of the plastic that's been covering surfaces, cleaning the surfaces underneath to be absolutely sure that we're meeting those lead hazard numbers and not leaving behind a lead hazard after the work. So this slide just shows us an example. This would be an exterior job where they're working on these windows. Looks like the preparation is still in progress on the left-hand side, working on these window trim and various ways to catch chips, catch dust, and prevent it from getting on the surface, for example, of this wall with plastic sheeting, also plastic sheeting on the ground surface, so that all the lead dust will be captured there. When this sheeting is pulled up, the surfaces underneath should remain clean. So that covers lead in paint and soil. I'm going to turn it over now to Lydia, and she will cover for us lead in school drinking water.
Thanks, Steve. All right. In case you couldn't tell, Steve he's out of the office. He's traveling at the moment, hence the complimentary soundtrack. Okay, so lead in school drinking water. So why are schools higher risk when we talk about lead in drinking water? So obviously, like Steve talked about, we know that children are especially susceptible to health effects of lead. I want to add another point, just because it's not often brought up, is that a large proportion of school staff tend to be women. And women actually are high risk because lead can actually transfer to babies during pregnancy and nursing. So even lead from past exposure is stored in our bodies and is released and can be released later in life during pregnancy and nursing. So yeah, just an extra tidbit there. So another factor is that obviously children and staff, they spend a lot of time at school, so that increases exposure. Older plumbing materials. So a lot of our schools are old, we know, and older facilities have a greater likelihood to have higher levels of lead. Schools also have intermittent use patterns. So what that means is they have periods like weekends, breaks when the water just sits unused. So this stagnation is a problem because it increases the potential for lead to leach into water the longer that the water remains in contact with any leaded plumbing materials. So for all of these reasons, the EPA recommends that schools and childcares have a program in place for reducing lead in drinking water. And that's what we'll discuss here in a little bit. But finally, the reason lead is still a risk in school drinking water is that the regulations that are currently in place are not adequate. So this may come as sort of a surprise because the EPA does have an enforceable standard of 15 parts per billion. However, that standard applies actually only to public water systems distributing the water. So once that water arrives at the property, the water quality is actually the property owner's responsibility. It's not the government's anymore. So in other words, a school can have very high levels of lead in the drinking water, and that is perfectly legal. So some states like California have started mandating testing in schools to try to identify those lead problems, which has been a good start. But there were some limitations with that testing, and we'll talk more about that. Okay, so how does lead get into the water? So lead has been commonly used in plumbing components because it's easy to work with. It's actually still used in plumbing components, in fact, just in lower allowable amounts. Okay, so lead plumbing components, they can be found in the distribution system, which is the network of pipes that carry water from the treatment plant to the buildings, as well as various plumbing components along the way from the water main to the point of use fixture, like the faucet or the drinking fountain. Potential sources of lead include lead pipe, meters, valves, lead solder, joints, brass components like angle stops, and aerators. So you can see some of those depicted in the picture. And then the result is lead in the tap water. So either it comes in two forms. It could be either in a soluble form or as particulate. Okay, so are there currently high levels of lead in the drinking water in our schools? So the simple answer is that we don't really know because generally schools are not required to test for lead in their drinking water. So to give you an idea of the country as a whole, so a survey of public school districts in the US was conducted in 2017, which found that actually the majority of schools in the country either had never tested for lead or didn't know if they had done testing in the past. And then of the schools that did conduct testing, about a third did find elevated levels of lead. Which brings us to the recent testing here in California, which is one of the states that has required some lead testing at schools recently. So those of you here in California are probably familiar with the lead testing at schools several years ago. So from 2017 to 2019, the state required water systems to test for lead in K-12 schools. So the testing was fairly limited. The testing required, the program required testing of 5 fixtures at each school. It did not require all the drinking water faucets to be tested. Also, it only required remediation if the level was over 15 parts per billion, which is the EPA's federal standard. However, the EPA itself says that 15 parts per billion is not adequately protective of health. So sort of like what Steve was saying, just because it's the regulation doesn't necessarily mean that it's health-based. So the 15 parts per billion federal standard is actually based on just what is currently feasible to achieve. Okay. All of the data from the testing is now publicly available online. You can view maps like this one that kind of show you where the schools are that did have elevated levels of lead. So based on the results, elevated levels of lead were found in many schools. 19% of schools had results above 5 parts per billion, and 5% of schools had results above 15 parts per billion. Okay, so California AB 2370 was the more recent regulation passed for lead in drinking water. Again, many of you are also familiar with this one. So this specifically required all California childcare centers to test their drinking water. So this included a lot of childcares located on school campuses and colleges. This program was a lot more comprehensive than the previous school testing in that it required all fixtures at the childcare that are used for drinking or food prep to be tested, not only the 5 fixtures required in the school testing. So according to the EPA, testing all of the fixtures is best practice because you can't assume that one fixture is representative for other fixtures at a site. For the childcare testing, remediation was required if the results exceeded an action level of 5 parts per billion, which was 3 times lower than the 15 parts per billion required for K-12 schools. So a far better action level from a health perspective. Okay, and the childcare program requires retesting periodically every 5 years instead of just a one-time thing like the school testing program. So this is best practice because lead levels do change over time and they can go up. Okay, so again, the results for this testing is also publicly available. Okay, so we looked at that data. So all of the data from the school testing and the childcare testing is publicly available online. What the results showed altogether is that about 1 in 4 sites in California roughly had elevated levels above 5 parts per billion. The highest result was actually at a childcare center in San Diego, which had over 11,000 parts per billion of lead, which is pretty horrifying. From our own experience being involved in some of the testing at the childcare centers, we saw that levels were not always consistent throughout a site, meaning you'd have a sample result from one drinking fountain that would be fine. It would be low, and then the fixture next door would be high. So, this is an important observation, and it supports why the EPA states that one fixture is not representative for the other fixtures at a site. There are, actually a lot of variables involved. As far as sources of lead, we saw that the fixtures themselves were usually the main source of high levels of lead. So when the sites replaced fixtures, that usually brought the lead levels down. So sometimes that didn't work, replacing the angle stop, which is the shutoff valve, had to be done as well. But generally speaking, most sites did not have to touch any of their interior plumbing. And incoming water was generally not found to be a big issue. Okay, so some other takeaways. So the only way to know if there is or isn't a problem with lead in drinking water is to perform testing. So a lot of times our own assumptions were wrong. So we would find elevated lead levels at relatively newer buildings as well as at newer looking fixtures. Another concern that came out of this, so some of the childcare centers where there were exceedances were located on school campuses. So the childcare portion of the school campus, they may have identified elevated levels of lead and have to replace fixtures. But meanwhile, the rest of the school possibly has similar issues, but because of the gaps in the K-12 school testing program, those fixtures may not have been identified or addressed. Also because of the the reduced number of fixtures that need to be tested, and the difference is in remediation trigger level. So it just kind of highlights the importance of schools being very proactive about assessing for lead in drinking water, because that K-12 testing program was very limited. Okay, so the big picture takeaway is for schools to be prepared to address their water quality. So there are some trends that will cause lead in water and water quality in general to become more of an issue. Okay, so there's, as far as regulations, so there's already a push for more legislation on the state and the federal level to try to identify lead problems at schools. So AB 249 is a bill that in California that would have mandated testing of all the fixtures in schools. Unfortunately, it was vetoed last year. The federal EPA is also working on mandating testing of lead in schools and childcare facilities on a federal level. And then as far as action levels, we can expect action levels to continue to get lower. All the public health agencies agree currently that there is no safe level of lead exposure, and that the ultimate goal is to get to zero exposure. And then water conservation and drought is another trend that is going to worsen water quality issues. So when you have reduced water flow, that water sits in the pipes longer and has more time to accumulate contaminants like lead and Legionella. As a result, we're going to see an increase in water quality issues in buildings. And then there are already school districts that are leading the way with very proactive lead programs. So San Diego Unified, Oakland Unified, Berkeley school districts are some examples. So they are already incorporating things like regular testing for lead, action levels of 5 parts per billion or even 1 parts per billion. Or they have gone ahead and installed permanent water filters at all of their drinking water outlets. So eventually, we predict that filtered water will become sort of the expectation from people. Okay, so let's talk some more about best practices for schools to reduce lead in drinking water, given what we know. So how do we implement a program to reduce lead in drinking water? Okay, so I want to make sure that everyone is aware of this guidance document from the EPA. So it is the EPA 3 T's document for reducing lead in drinking water. The 3 T's stands for training, testing, and taking action. So this is probably the best resource on the topic of lead in drinking water in schools. And it is freely available online on the EPA website. You can just Google EPA 3 T's and you'll find it. So there's a landing page with various resources, including the main guidance document, and it's got recommendations on how to address lead in drinking water in schools and childcare facilities. Okay, so this is just kind of I'm going to kind of summarize some of the key points in the EPA's guidance. So to start, you want to gather any information that's already available. So if there's been any testing conducted previously or information on any plumbing components with lead that have already been replaced, go ahead and gather that information so you have an understanding of what your building is like. Seek out partnerships. So reach out to your public water system or your local health department. They may have resources to help you, so you're not alone. There's a lot of resources that are already out there. Develop a plumbing profile of your schools to determine whether lead is likely to be a problem at the school. Okay, so say you have 20 schools across your district. Where do you begin? So asking certain questions will help you to prioritize your efforts. So if you download the 3 T's document, that has a good list of questions to start with. So for example, when was the building constructed? You're generally going to want to prioritize the older buildings. Are there signs of corrosion, such as leaks or rust-colored water? Have there been any complaints about metallic or a bad taste of the water? And then this is an interesting one, is any electrical equipment grounded to water pipes? So this is interesting because there's apparently a practice of grounding electrical equipment to water pipes. So this is not good if there is any lead in the pipes, because the electric current actually accelerates lead corrosion. And we actually worked with a school that had very high levels of lead in their drinking water, and they ultimately determined that it was related to this. Okay, so then developing a sampling plan. So identify all of the fixtures at the school that are used for consumption. So that is fixtures that are used for drinking water or food prep, and plan to test all of them. Prioritize sites based on their plumbing characteristics, like we talked about, and those that might be used by the youngest children, right? So prioritize your childcares and your elementary schools. And then as you prepare for sampling, determine which threshold you're going to use as an action level. We've taken the liberty of crossing out the 15 parts per billion there, because that is way too high. Even though 15 is the EPA's current drinking water standard, the EPA itself states that that is not adequately protective of health. Public health guidance tells us to go lower than that. So 5 parts per billion is a reasonable target. That was the action level that was set for the childcare program. 5 parts per billion is actually the limit, FDA's limit for lead in bottled water. And then some districts have chosen to go even lower and aim for 1 parts per billion, which is actually the limit that's recommended by the American Academy of Pediatrics. Okay, so as far as sampling, I won't spend too much time on the details, but the EPA does have very specific guidance on how to conduct the sampling, even things like how long the water should be sitting prior to testing. It's very prescriptive. Okay, so once you get the results, you're gonna want to compare your results to the remediation trigger level that you selected. If you have, multiple fixtures that are above that level, you're limited on resources. Prioritize remediation at the outlets with obviously the highest levels and those that are used most frequently by the youngest kids. Start figuring out where the lead is coming from. Like I mentioned earlier, generally the most common sources we saw were usually at the fixtures themselves, so just localized contamination, or could be particulates built up in the debris in the aerator or the screen. So usually, replacement of the outlet itself was the solution. Communication. So communicate the results to the school community and let them know what the plans are for remediation. Then a little bit more on communication. So transparency and communication are really important. Ideally, communicate before sampling, once you get the results, and explain what the plans are for remediation. So it just lets the staff and the families know that you're committed to protecting everyone's health. And the EPA 3Ts document actually has a lot of helpful tips on communication, and it even provides some templates that you can use for notifying parents and staff. If you have results that show elevated levels of lead, take those outlets out of service. You can use them for hand washing if they're being used for hand washing. Just don't drink out of them. Some short-term measures could be installing filters, flushing the taps before you use them, providing other water sources in the meantime, while longer-term measures are being considered. So replacement of the problem fixtures is usually, it's the most common and usually the most effective solution. Replacing lead pipes or lead service lines. So usually we have not seen that facilities have to resort to this from our own experience here in California. Some schools have opted for filters at their drinking outlets. Just keep in mind that it does require regular maintenance and expense with all of the filter changes. And then after doing remediation, do follow-up testing to make sure that the levels have been reduced. Replacement of fixtures. Make sure that the new fixtures are lead-free. So the EPA has guidance on how to identify lead-free plumbing fixtures. Just be aware that the term lead-free actually doesn't mean 100% lead-free. It just means that it's below a certain allowable percentage of lead. A very small amount of lead is allowed to be in fixtures. Okay. And there's certain certification marks you can look for to identify low lead fixtures. The fixture needs to be certified to have both a low content of lead and also a low potential for leaching of lead. Okay, so these are two separate things, but they're both important. And be sure to flush the new fixtures after installing them. So ideally, several times a day for the first few weeks. Why is this? It's actually because new fixtures can leach higher levels of lead in the beginning during sort of a break-in period. So some schools are choosing to go ahead and install point-of-use filters at their drinking water outlets, particularly at the bottle filler stations. So this is one option. Just make sure to select filters that are certified to reduce lead. Check with the manufacturer or a third-party website, such as nsf.org, to verify that the product is certified to remove lead and to remove particulates. And of course, stay on top of filter replacement. So the EPA also has a list of banned drinking water coolers. So if you have any that are on this list, they need to be removed. So these are sort of like low-hanging fruit. You don't even need to test the water to find out if they're a problem. You can find this list on the EPA 3Ts document. And if you have any of these old drinking water coolers, go ahead and remove them because they are not allowed. And then finally, here are some general tips to reduce your exposure to lead. And this is applicable everywhere, whether at work, at school, even in your own home. So consider testing for lead. The analysis is pretty affordable, actually. You can reach out to a lab or even purchase a kit online. Consider point-of-use filters that remove lead. I know these are very popular for people to use at home. Let the water run or flush the tap before using it for drinking or cooking anytime that the water has gone unused for more than a few hours. So use only cold water for drinking, cooking, or mixing baby formula. So this was really interesting to learn because I used to think that I was very clever by using hot water from the tap. Anytime I had to like boil water to make pasta or something like that, I would just use hot water from the tap to save myself a couple minutes as I'm boiling the water. I don't use that anymore. Hot water actually tends to have higher levels of lead just because the higher temperature will leach lead if there are leaded plumbing components. And then finally, if there's screens or aerators in your faucets or drinking fountains, make sure that they are regularly being cleaned. So, because you want to prevent accumulation of debris and particulates that can collect on the back of the screen that can contain lead. Okay, so we're almost at the end. So finally, I like to end with this graph because I find it very interesting and very actually quite empowering. So it shows how lead exposure in children has gone down over time due to lead prevention policies. So the x-axis is a timeline from the 70s to today, and the y-axis is average blood lead levels in children. So you can see the level of lead exposure has fallen pretty dramatically over the past several decades because of public policy. You have these blue call-out boxes that talk about different lead regulations over this time period. Some of the major ones are the phase out of leaded gasoline, reduction of lead levels in household paint, in food cans and industrial emissions, reduction of lead in drinking water, and just a variety of public health initiatives that have targeted this problem. And it just really helps to sort of illustrate the journey that the country's on to reduce lead exposure. And it just really shows how much progress has been made. So with that, I'll turn it back to Taylor.
Thanks, Lydia, and thanks, Steve. We will open it up to questions now. So if you have not yet put your questions into the question and answer section and have any, please do so now. We do have a few that came in though, so we'll get started with those. The first one being, did AB 746 collect 1 liter of water? AB 2370 collected 250 milliliters, which focuses on just the faucet.
That's a good question. I know AB 2370 required a 250 ml sample. I'm not totally sure about the, I think they were asking about the K-12.
AB 746.
746, yeah, I believe that's, I don't remember this, the number. 746, yeah. Yeah, I don't know because we weren't involved with the testing for this. I think this, it was in the school testing program, it was the public water systems that were performing the testing. So I don't know what sample size was required. But yeah, as far as differences in sample size, a smaller sample size is going to tell you more about like localized contamination. So the 250 ml sample is going to tell you more if there's contamination from the fixture. A 1 liter sample, that's pretty big. So that you're going to be pulling water not only from the fixture, but potentially the upstream plumbing. So it might sort of, dilute the sample if you did have contamination from the fixture. And, the result would be, sort of obscuring the problem with the fixture. If they were using 1 liter sample, I actually do. I'm not sure, but that's an interesting question.
Great, thank you. The next question is, have you heard if AB 2370 will be extended down to home childcare facilities?
I have not heard. Yeah, so AB 2370 did not include household childcare centers. And I haven't heard if it will extend to household childcare centers, just because I imagine they're regulated differently. So, I mean, it would be great if they could be regulated, but at this point, I haven't heard whether they will extend that regulation.
Okay. Next question. So if using warmer water increases the likelihood of lead leaching into tap water, what does that imply for washing hands in warm water, especially before preparing food?
Yeah, I wouldn't worry too much about that. As far as the lead that would, the residual lead that might be on your hands from washing your hands with warm water, I wouldn't expect that. That would be so low by the time it gets to the food, I wouldn't be too concerned. But for the most part, yeah, you can wash your hands with lead water and you'll be okay. Just don't drink it. But yeah, it was certainly something that it was interesting for me to learn, having like a young child myself. But if you, glean anything from this, if you have any friends or family that have babies, anybody who's using tap water to mix baby formula, let them know. Don't use warm or hot water from the tap. Use cold water from the tap. And then warm it up.
All right, next question. Why is it recommended to do retesting for lead every few years if test results were low and nothing has changed since then?
Oh, that's a good question. Okay. So, let's see. So AB 2370, they require retesting every 5 years. Okay, so lead in drinking water is not it's not fixed. So there are a lot of factors that can influence the levels of lead. So not only the lead content of the plumbing components, right? The water chemistry, the pH of the water, the temperature of the water, the frequency of use of the fixture, stagnation, whether or not the public water system adds corrosion inhibitors to the water. So all of these factors can impact the amount of lead that can leach into the water, and any of these factors can change. So we actually we saw this in Flint, Michigan. So when the city changed the source of the water, it wasn't that the source water contained more lead. It was just that the water that they changed to was more acidic. And then that resulted in more lead to leach from the city's lead pipes. So, I mean, basically, there's so many factors involved. So you can't, if you do testing, that's one snapshot in time. And because of all these different factors and variables that can change, you're going to want to retest just because those factors can change over time.
All right, and one final question here. We'll close it out after this one. We've only got a couple minutes left. But for outdoor lead work, how is dust controlled when it's windy or raining?
Right, so there we're looking at weather conditions in advance, and you're basically predicting the weather, and you're making it such that you're not working when it's raining, when it's going to be windy. And the planning involved in that is primarily, if you're in the middle of the job, don't prepare so much that you can't complete it before that wind or that rain is coming, because it will blow apart your containments frequently. It can be done, shrink wrap and such, to withstand more weather, but usually the idea is to simply not be working in those weather conditions.
All right, thank you, Steve. And that concludes our webinar for today. Thank you all for joining us. Again, we apologize for the background noise. We'll send out a recording. We're going to try and get that background noise out of there, re-record it, so everybody's got a copy of this presentation. Please reach out if you have any questions at all that weren't answered today. We will also send out Lydia and Steve's contact information if that's helpful at all to you. But please, again, thank you for joining us. Reach out if we can help with anything else. And thank you, Lydia and Steve. And have a good one, everybody. Take care.